Hello students, today already I have sent you the message of getting ready with a graph paper so that I can show you graphical representation of motion. Graphical representation of motion. Regarding motion, I think it is clear to you. Already I have taken so many classes regarding this chapter. So today I will go on discussing based on graphical representation of motion. It is very important topics of this chapter, motion and measurement. Now let me start. I think all of you are seeing this graph, and you please go on tracing as I discuss. So distance, this is called distance time graph. Distance, this is called time distance time graph. Distance time graph. The distance, what is called distance time graph? The distance time graph of an object, maybe car, maybe bus, maybe cycle, whatever may be, which are in moving condition with a uniform speed. With a uniform speed. That means the speed will be constant. That means each interval of time, that means first it starts from 0, then we in 1 second or 1 minute it will cover suppose 5 kilometer. Then next 1 minute or 1 second it will cover again 5 kilometer. Just like this, always the distance will remain same with the time. So when an object, try to listen and follow after me. When distance time graph for uniform speed, distance, this one is distance time graph for uniform speed. For uniform speed. When an object moves with a uniform speed, that means speed will be constant. It travels, listen carefully, it travels equal distances in equal intervals of time. Equal in distances in equal intervals of time. So that we can say that the distance traveled is directly proportional to time. If distance will increase, time also increase. That means the moving object with a uniform speed travels equal distances in equal interval of time. Equal distances in equal interval of time. I think it is clear to you that uniform speed, that means uniform speed means equal uniform speed. Uniform speed means distance traveled. Distance traveled is directly proportional. This is the symbol of directly proportional to time. That means if the speed will increase, then time also, in respect of speed, time also will increase. When two things are directly, that means two things means here distance and time, these two things are directly proportional to each other, the graph between them is a straight line. That means this one, y-axis distance I have taken and x-axis time. So when the moving object is in uniform speed, the distance and the time are directly proportional to each other. That means with the increase of time, the distance also increase in the same ratio. So you see, And what will be our graph? So in this case, in uniform speed, that means when two things are directly proportional to each other, the graph between them is a straight line. You see, it is a straight line. The graph between them, that means between time, distance and time, the graph, if we go on stretching the line according to the changes of distance and time, we will see that the line will be straight line for uniform speed. So by seeing, if a question comes, what type of speed in between this between distance and time, you have to write it is in uniform speed, as because here you see the graph between distance and time is a straight line path. Is a straight line path. This one is straight line path, and it is the comparison between distance and time. X axis means time and y axis means distance. Thus, the distance time graph of an moving object, that means object is in moving with a uniform speed or constant speed, is a straight line. Is a straight line. So I think it is clear to you. The straight line, you see, the straight line OA. Suppose OA, this OA is sloping upward, showing that is sloping, you see, sloping upward with the increase of time and with the increase of distance. We are sloping upward, showing that the time increases, the distance traveled by the object also increased. As the time increases, distance of the distance traveled by the object also increases in the same proportion. You don't forget that when directly proportional, then you have to write the time increases, the time increases, the distance traveled. You have to write the distance traveled by the object increases in, don't forget to write, in the same proportion, in the same, you have to write by seeing if this graph will come, you have to write in this way, in the same proportion. So what you have to write? As the time increases, the distance traveled by the object increases in the same proportion. In this case, uniform speed, you have to write this answer by seeing the graph. If the graph comes and if it is directed that what is your answer based on this graph, distance time graph for uniform speed, this line will not be mentioned for uniform speed. So what to write? That by seeing the distance and the graph between distance and time, it shows uniform speed, as because the graph shows a straight line. You have to write the distance, it is distance time graph. So distance time graph of an object, the distance time graph of an object moving with a uniform, first of all you have to write this one, uniform speed. What do you mean by uniform speed? Or constant speed. See, speed in a straight line, in STRAIGHT, straight line. This one you have to first write by seeing this graph. The distance time graph, it is between distance and time. OX represents time and OY represents distance. The distance time graph of an object moving with a constant speed or with uniform speed in a straight line, this is straight line. What to write? The distance time graph of an object with object moving with a uniform speed or constant speed in a straight line. As the time increases, then you write this one. As the time increases, the distance traveled by the object increases in the same proportion. As time is increasing, distance is also increasing in the same proportion, not haphazardly. So in this uniform speed, what to write by seeing the graph? It will not be that uniform speed, it will not be written, and just this diagram will be given on the paper. So what do you mean by this graph? So what to write? You have to write this is a distance time graph of an object moving with a uniform speed or constant speed in a straight line. Then as the time increases, the distance traveled by the object increases in the same proportion. You have to write this. Now, you see, next one. I think all of you are seeing this graph. The first one is distance time graph based on uniform motion. Based on uniform motion. Then, but if this will come, then you have to write the distance time graph of an object. It is in moving. So, object moving with a uniform speed or constant speed in a straight line. And the distance, and we know that the distance, we know that at this one, the distance traveled is directly proportional to time. As the time increases, what do you mean by directly proportional between distance and time? You have to write as the time increases, the distance traveled by the object moving in the same increases in the same proportion. Then next come this one. Are you seeing that this one is more steeper than this one? Kharai. Steeper means kharai. This straight line is more steeper than this one. So by seeing, what do you mean? That means this is slope. This is slope. The slope or slanting line. The slope or slanting line of a distance time graph OA and OB. These are the slanting lines or the slope. OA is one slope and OB is another slope. To compare between the speed of the two objects. You see, from this we can say that if the distance time graph, how distance time graph has a low speed and higher speed. Low speed shows this one OA, that means low slope. Low slope means less steep. Low slope means this one OA. OA is has a low slope. Has a low slope. Has a low slope, and that means it is less steep. Kam kharai. And OB, what will be OB? OB, OB represents higher slope, higher slope, great, then higher slope, higher slope and greater higher slope, greater steep. Kharai. So you see here OA lower speed and OB higher speed, as because thus by seeing the slanting lines OA and OB in the distance time graph indicates the speed of the object. You by seeing the slanting or the slope, you can guess that which one is in higher speed. If the distance time graph has the lower slope, that means less steep, lower slope or the less steep, that means the object has low speed. On the other hand, if the distance time graph shows the higher slope or more steep, higher slope or greater or more steep, higher slope or more steep. So OB, the slanting line OB, on the other hand, shows that it is more steeper than OA, the slanting line OA. So it indicates that the car in this slanting line is in higher speed. Again, I'm telling the slope or the slant of a distant time graph indicates the speed of the object. If this will come from this, you can say which one is in higher speed and which one is in lower speed by seeing the slanting line and the steep. If OA is the slanting line, it shows that it is in less steep. If you compare with the time OX graph axis, you can see that it is in low speed. So you see the graph and I'm telling the slope or slant of a distance time graph indicates the speed of the object. If the distance time graph has the low slope or less steep, that means OA. OA is in position of low slopes or less steep. That means the object has low speed. Now, on the other hand, the distance time graph of a higher slope, that means OB is higher in comparison to OA, that means it is in more steep and then the object is in higher speed. So how what we have to write, that you have to write if the distance time graph has a low slope or less steep then the object has low speed. Just opposite in this case, if the distance time graph has the higher slope, that means OB or more steep or more steep then the object has higher speed. Higher. Why higher? Because you are comparing with OA. You see what to write. If the distance time graph has a low slope, that means low slope means this one OA, OA has a low slope, less steep, kam kharai, then the object has low speed. If the distance time graph has higher slope, has a higher slope, SLOPE, OB, more steep, then the object has higher speed. I think all of you have followed me. So these two, this one for the graph showing the distance time graph showing uniform speed, and this one distance time graph showing and OA and OB, this slanting lines showing for the motion of the two objects. Which one is less steep? That means it shows lower speed, and which one is in more steep? That means OB, showing that it is in higher speed. And you see one thing also you can mark it, OA and OB, which one makes greater angle with this with time graph, that means on the x-axis. Naturally you see OA and OB makes a greater angle in comparison to AOX. So it the object which is in higher speed, it makes a greater angle. It makes a greater angle with x-axis. The in comparison to the object, moving object which is in lower speed. You see OA, it makes lesser angle with the x-axis in comparison to the object which is in higher speed. This is also one reason. You see, OB, it makes a greater angle in comparison to OA on the x-axis, and OA, this which the object which is in lower speed, it makes lesser angle with the x-axis in comparison to OB slanting lines or the more steep line. OB, the slanting line, which shows that the object is in higher speed in comparison to OA. That means greater the angle with the x-axis, more will be the speed. Distance time graph with non-uniform. That means the speed is not constant, continuously changing. In where it is happening? In congested, where it is happening in congested road, or where the traffic is more, or sometimes brake is applied by the driver due to the signal, due to the signal light, or maybe due to the traffic. So that time the speed is continuously changing, and that is called non-uniform speed. That means speed is not constant. When an object moves with a non-uniform, this graph, non-uniform speed, or keeps on changing the speed, it travels unequal distances in equal intervals of time. Unequal, you see, due to unequal distances, this graph has become curved. This due to unequal distances, we in respect with the time, you see the distance time graph, the distance is, you see, curved. So but you see in equal intervals of time, that means first 1 minute or 1 second it has traveled 5 kilometers, the next 1 minute it has traveled 2 kilometers due to traffic on the road, and again it increased its speed due to flat and non-traffic area. Then again driver has to apply brake due to the traffic signal. Like this, continuously the speed of the moving object is changing, and the practical example is, you see, in practical example is when you are traveling by train, you can observe that when it starts from the station, that means when an object when in suppose I'm telling with an example, When an object moves with a non-uniform speed or keeps on changing, it travels unequal distances in equal intervals of time. That is why the distance time graph, the distance is showing curved line on the graph. In this case, the distance traveled is not directly proportional with the time, as because with the increase of time, the speed may be increase or decrease. The distance time graph of an object moving with a non-uniform speed or changing speed is a curved line. You see, this one is a curved line. Thus, a curved line graph between the distance time tells us that the object is moving with a non-uniform speed. That means speed is changing. The distance time graph in the form of curved line tells us that the object is moving with which is not constant. So by seeing this one, what to write? The distance, only this one you have to write. The distance graph in the form of a curved line tells us that the object is moving with a speed which is not constant which is not constant. This is very important. The distance time graph in the form of a curved line tells us that the object is moving with a speed which is not constant. That means keeps on changing. Distance time graph here. Distance time graph when the object is stationary. That means stationary means not moving. After traveling a certain distance, when a moving object stops or parks, then the distance traveled by it does not change with the time. Time you can't stop, it will go on. So what is happening in distance time graph when the object is stationary? After traveling a certain distance, when a moving object stops moving or becomes stationary, then the distance traveled by it does not change with the time. It remains same. Because suppose after moving some distances near the market, if I park the car, so that means the moving object is in stationary condition, but the time do your wristwatch will stop according to the car? No, it keeps running. That is why it has been written that distance traveled by it does not change with time. This line, distance traveled by it does not change with time. That means in this case, you see, when the car is in stationary position, the graph will be parallel to the time. Car is in stationary form, that is why straight line, but time is changing. That is why the graph will form like this. This is the car traveled up to OA. Then after parking the car, the line will be straight, parallel to the OX axis, OX axis which denotes the time, which time is changing, but the moving object, and that means car, is in stationary condition. I think all of you can follow after me. So when an object becomes stationary, its speed is 0. That means the car is not changing its place, so its speed is 0. So a straight line graph parallel to the time axis shows that the speed of the object is zero with respect to the change of the time. Speed of the object is zero with respect to with the time. Car parked on a side road, when it has stopped moving and become stationary, you see, then up to OA the car has traveled. But in this, after reaching A, time is changing. But you see, as because the car is in parking, it is its speed is zero, and that is why it shows parallel line with respect to the x-axis. That means which denotes time graph. Now from this, 1, 2, 3, 4, uniform speed, then higher speed, lower speed, then curved line, that means comparison between distance and time graph. If we get curved line, that means keeps and the moving object changes its speed, and with the time, with equal intervals of time, with equal intervals of time. That means speed is not constant, and when the car is in stationary position, but the time is keeps on change, time or will not wait for any with in the change of time, it shows parallel to the time graph, that axis, that means OX. So we can get the following conclusion and discussion on distance time graph for a moving object. We can say, if the distance time graph, if the distance time graph of an object is a straight line, you see this one, then we have to say that the moving object, that means maybe car, maybe bus, is in uniform speed. What do you mean by uniform speed? The distance time graph of an object moving with a uniform or constant speed in a straight line. Why? Because we know that the distance traveled is directly proportional to time. As the time increases, the distance traveled by the object also increases in same proportion, also increases in the same proportion. The next one, if the distance time graph of an object is not a straight line or it is a curved line, then we have to conclude that the speed of the object is not constant. The speed is changing. If the distance time graph of an object is a horizontal line parallel to the x-axis, that means time axis, x-axis is also, you can say, time axis, then the speed of the object is zero. That means the car is in resting or in stationary position. It is not moving, it is stationary. It is stationary. An object moving along a straight line, this one, or a straight line path, is said to have uniform motion if the speed remains constant. So in this case, in this first one, uniform speed, what to say? An object moving along a straight line path. You see, straight line path is said to have uniform motion if its speed remains constant. But it is not possible in our daily experience, because an object having uniform motion travels equal distances in equal intervals of time, and the motion of the car is at a constant speed, is the example of the uniform motion. So will the car move with uniform speed on a road? No. Sometimes brake may be applied, sometimes it stops due to traffic signal, and in an congested area you have to operate the brake. Now, an object moving along a straight line path is said to have non-uniform speed when the speed keeps on changing and it does not remain constant. And the practical example, you see, the motion of a train starting from railway station is an example of non-uniform motion. So when it is on the platform, that means it is stationary. Then as the signal given by the signal man, what it happens, its speed goes on increasing, and when as it moves more and more distance in each 1 second, 1 second or 1 minute, 1 second or 1 minute of time interval. That means time after each 1 minute or 1 second or 1 hour, you see, up to 1 hour, it won't control. Frequently, it's changing, and the train is changing its speed as it moves, as is and when it is in stationary, when it is on the platform, when it is on the platform. So we can say when a stationary train, that means when the speed is zero, starts from a railway station, its speed gradually increases as it covers more and more distances, as it covers more and more distance in each 1 second time interval, 1 second time interval. And when the train approaches to the next station, that means it has to be stopped. So what is happening? Its speed goes on decreasing, due to which it covers less and less distance in each 1 second time. So this is the example of non-uniform motion. So what is non-uniform motion? The non-uniform motion in which the speed of an object keeps on changing. What do you mean by non-uniform motion? Non-uniform motion means that the speed of an object keeps on changing, is also called accelerated motion. Sometimes it slows down, sometimes it increases its speed, sometimes and when it reaches nearby next station, and its speed decreases, and gradually covers less distance in each 1 second time. And when it is in stationary, that means in the platform, then when it starts from zero speed, its speed goes on increasing and it covers more and more distance in each 1 second and time interval. As the train approaches to the next station, its speed goes on decreasing, due to which it covers less and less distance in each 1 second time interval. I think it is clear to you, and but this much is for this chapter already, and I will take another one more class for revision. That means for recapitulation, I think it will be needed. And next day, I will discuss more and more questions from the exercise. That day already I have discussed that short type question, motion of your hands while running. It is periodic motion. Motion of a horse pulling a cart on a straight line, that means rectilinear or linear motion. In short, you can write motion of a child on a seesaw, that means periodic motion. Motion of a hammer of an electric bell, periodic motion. Motion of a train on a straight rectilinear motion or linear motion. Then what type of motion is represented by the following? Soldier in a march past, linear motion. Pedals of a moving bicycle, circular motion. Hands of an athlete, periodic motion. Bullock cart, linear motion. Spinning of earth, rotatory motion. That means earth spins round on its own fixed axis, and like a spinning top, it is called rotatory motion. Then draw the distance time graph. for an object moving at constant speed. That means a straight line path between distance and time graph. For a stationary object, when it is not moving, that means horizontal line parallel to the time axis, that means x-axis. A train having, a question also already numerical, a train having speed 75 kilometer per hour, 6 hours to travel. Then what? Calculate the distance. Distance equal to speed into time. Speed into distance. Distance equal to speed into time. Don't forget to write the unit. It is very much necessary. If you won't write unit, then your numerical will not be correct. Some examiner will give you, if the answer is correct, some examiner will give you half marks or may not give. That is why unit is must. Unit is must. A train running a speed 75 kilometer. That means in 1 hour it goes 75 kilometer. 1 hour. The distance traveled by the car, train 75 kilometer. So in 6 hours it will cover the distance. 75 into 6 equal to write the answer, and calculate the distance. Distance always in kilometer. Then a car is running. A car, you see how kilometer? 75 kilometer. Speed means per hour given, and into 6 hour. So you see 6 hour and hour will be cancelled. 6 into 75, whatever the answer, it will be in kilometer. Hour and hour. Per hour means, you see, kilometer by hour. And in 6 hour, hour will be cancelled and the answer will be in kilometer. A car running at a speed 60 kilometer per hour. 60 kilometer per hour. How much time will it take to cover 270 kilometer? So you know speed, time. Time equal to distance divided by speed. And distance 270 kilometer. Speed, you see, speed 60 kilometer per hour. Write like this. Now 270 kilometer into 60 into see hour. I'm showing again. Here you see. Here is time means you have to write the answer in hour. And the total distance is 270 kilometer. And here is 60 kilometer per hour means divided by hour. So in division, you know that you have to reciprocate. So 270 kilometer into hour by 60 kilometer. So kilometer will be cancelled, 0 will be cancelled, then 27 by 6. 27 by 6, 27 by 6. So 6 3s are 18, 6 4s are 24, 6 4s are 24, 3 by 6, that means half, that means 4.5 hours. Time short, always hour, minute and second. So that is why I am advising you, you please learn by heart. Speed equal to distance divided by time, distance equal to speed into time, and time equal to distance divided by speed. So you see, it will be easier for you if you, from the very beginning you can if you write kilometer per hour. How you have to write? Kilometer divided by hour. So to find, you see, I have shown you that you have to find time. Time equal to distance divided by speed. Distance means 270 kilometer and speed, you see, 60 kilometer per hour. Now per hour. Now reciprocate, it is the relation of division. So 270 kilometer into hour by 60 kilometer. So kilometer will be cancelled, 0 will be cancelled. Now divide 27 by 6, you will get the answer, and answer must be in hour. Here it is. Then next one. And next one, you see, I'm discussing this one. You see, in a distance time graph, what type of motion does a straight line represent? Straight line. Straight line represents uniform speed. Like this question will come. In a distance time graph, what type of motion does a straight line represent? Straight line represent that the object moving in a constant speed. In a constant speed with the constant speed with equal intervals of time. With equal intervals of time. Then what type of motion does a curved line represents? That means the object is moving with a with not a constant speed. That means speed is not constant. That means the moving object um, is keep is keeping on changing its speed. Is keeping on changing its. That means the speed is not constant. That object is moving with a speed which is not constant. It denotes what you will write. What type of motion does a curved line represent? The curved line motion, curved line graph between the distance time graph represents that the object is not moving with a constant speed. With a not moving with a constant speed. It keeps on changing its speed due to maybe congested area or traffic signal. Then state the type of motion exhibited by the following. Motion of a child in a merry-go-round, to and fro, that means periodic. Motion of the earth round the sun. Motion of the earth, circular path, that means circulatory motion. That motion of a pendulum, periodic motion, repeats its path in a regular intervals of time. Motion of a swing, to and fro, that means periodic motion. I think to my level based, I have discussed everything. Simple pendulum, what is motion, what are the types of motion, then first the object speed regarding slow and fast, then distance type time graph based on uniform speed, then the slow and higher speed, then curved line, that means not object is not moving in a constant speed, then horizontal parallel to the time axis graph, time axis, that means a x-axis, that means the car is in stationary or is at rest, that means it's when its speed is 0, when its speed is 0. So everything I have discussed. Now it's your duty is to read thoroughly the NCERT book and see it is clear or not, and I will take one more class for the repeated discussion of this chapter, motion and measurement. This much is all for today because I have the next class from 12:45. So thank you.